Welcome. So I know I haven't posted a video in a while, but then I went into the comment section of my old videos and I just felt, yeah, it is time again. So here we are, almost 2 years later, and I'm gonna build a OTF knife. It's also called a out the front knife or switchblade. And the reason why I'm building this is me as a kid. I remember watching the movie Terminator. You know, the scene in the beginning of the film when they just pull out their knives and it just flicks out.
Fuck you, asshole!
I always thought that was really cool, so I just thought, why not build it here, my room? I'll be showing you the whole design process and building process, everything. And I hope you enjoy. Stay tuned. When I first decided to make this project, I thought, how difficult can this even be? I first just need to look at some references so I know exactly what I'm gonna build. And then I just need to look at some pictures and some videos where they explain the mechanism itself and how it works. When I have that, I can use the knowledge to put it all on paper. And with the paper, it helps me to get a better understanding. Plus, it gives me a whole nother perspective on the whole knife. And that helps me a lot to put it into CAD, which stands for Computer Aided Design. And when I have that, I just need to print it and it'll be done. Or so I thought, at least. Turns out it's a bit more complicated than you would think to build the world's most complicated knife. So, to begin the project, the printer finally decided that it was time to come out the closet. It had been sitting there for many years, and like anything that comes out the closet, it gotta look beautiful. So I spent some time just cleaning it up, and also I'm gonna use it very much now, so I want it beside me at all times. The knife only consists of 4 main parts, excluding the feathers, so that's really calming when compared to the previous project I made with about 90 parts. But the thing is, with the knife, they all have to work perfectly together in order for the knife to work. I always draw up all of my parts on paper with somewhat accurate measurements and proportions before I design it in the computer. And like I said before, drawing it gives me a whole nother perspective on how I'm supposed to design it in the computer and also what I'm gonna design, because you gotta know the in and outs of the knife before making it. After many hours of just designing it in the computer in CAD, I finally had my first working model. Well, not fully working. I noticed that the hole I made for the spring itself was way too small for the spring. That means also that the mechanism does not work at all with this design. But I still went ahead and assembled the whole thing, just to see. And now, with the spring locks in place and assembled, I just need the blade and I can test this design. And also so I can see what I need to fix and change for the next prototype. But there was one problem. So the blade was just a little bit too thick for the body. So I decided to be the most lazy, productive person ever and just spent about 40 minutes sanding the blade down. That took about 30 minutes to print, so I can finally make it fit. But that didn't happen. So I just made a new one with the right dimensions. And also the small pin on the blade also had to extrude up, so it was a good idea for me to do what I should have done in the beginning and just print a new blade. With the new blade ready, I have finally all of the pieces I need, except the springs of course, to assemble the whole thing and just see how it works, and even if it works, so I know what to fix for the next prototype. I decided to use rubber bands as the mainspring for this prototype so that it could kind of work like the animation I showed you before. But this shortcut kind of came to bite me in the ass later because several reasons. The rubber band kept sliding against the holster or the body of the knife, making it less smooth, and also the rubber band wasn't giving me enough of the spring power I needed for the blade to shoot up and down. After putting all of the pieces together, I can now see what I need to improve upon for the next model. And trust me when I say this, there was a lot that needed to be done. This was only the first prototype out of many to come. But first, to see exactly what I need to fix, I have to make a working model where I can actually test and see if the spring mods work. After all of this time and anticipation, I can finally test and see whether the spring locks actually work. And they do, but the blade was very stiff due to friction. But I thought I can overcome that by just overcompensating with a stronger mainspring. So I went out and bought a spring kit with as small springs as possible. The springs were still a bit too big compared to the ones that the OFT knives use, but I was still quite confident that I can make it work somehow. Then I went ahead and printed a new and improved body and switch that's now compatible with the new compression springs. Unfortunately, the first print had some printing problems, so I had to print another set, but I could still use the middle piece from the first print, so that was nice. And here it was, fully assembled and ready to use. I have all the parts I need now, so in theory it should work, right? Well, wrong, because the friction problem I mentioned before turned out to be a massive problem. Friction was the biggest hurdle that I had to face in this project. To be able to overcome this hurdle, I have to make the parts that were rubbing out of a material that's pretty good with friction, such as metal. So that is what I did. I had this old Damascus blade just laying around collecting dust, old project of mine, but I decided that this project was a valid reason to sacrifice this old rusty blade. was 2 millimeters wider than the plastic one, so instead of sanding it down, I decided once again to channel my lazy productiveness and just make a new holster that's 2 millimeters wider. After that, I just needed to make it look and function like a real blade should, and because this is Damascus, we can't forget to etch the blade. So I put in some really concentrated coffee for about 12 hours, and then it looked like this. Finally, the last part I have to make for the knife to work. The spring locks. I took the wrench that came with the Dremel tool I've been using and used it as my spring locks. It was the closest and best thing I could find, so another valid sacrifice in my book. The reason why I'm filing and cutting it so strangely is because I want to file it to the correct size before cutting it off, because it's a whole lot easier to work with something when you can actually grab onto it. I did this once more for the other spring lock. After making them, the only thing that I had left was to make the knife look like it wasn't made in someone's bedroom. So I sanded it as good as I possibly could so that it could be ready for priming and then painting. In the final stage of this project, I encountered a quite dumb but still straightforward obstacle. The only screws that I could find with the correct diameter were too long, so I had to individually trim them down to size. With each cut, the switch knife came to life, a testament to determination and craftsmanship. This journey highlights that from raw materials to the finished piece, the persistence to turn nothing into something is what truly defines craftsmanship. And there we go, it is done. It is looking beautiful. It is not the sharpest knife in the world, but it cuts. So I hope you enjoyed the whole video, and leave a comment below what else you want me to build, and I will try my best to build it. But I hope you enjoyed this video. See ya.